And so we have a different perspective than what's going on here. And I know we're all interested in how does the regulatory framework fit into a decentralized world? Like, how do we bring these two pieces? How do we bring these two paradigms together? And the approach that we have been taking to do this at Stratumn is to figure out a solution through the workflow, through the business process. And so what I'd like to talk a bit about is what does that picture look like? What are the systems that we're developing? What are the technologies, the cryptography, and the methods that we're using to bring together traditional institutions such as financial services, banking partners, regulatory bodies, etc., with decentralized technologies such as blockchain, Bitcoin, cryptocurrencies, etc. And so, let's see if I can get here. Okay, so as I mentioned, I want to frame this in a certain way that makes sense with some concrete issues at stake. What's on the table? What are we trying to solve? And how does that transform? How does that take us from a previous paradigm to a new paradigm that brings us together? And so when we look at the business world, we see all these workflows and processes, and we can identify three problematic reoccurring issues within this framework. The first one is the fundamental issue of your database is on your side of the fence and my database is on mine, and we have a trust issue. Okay, this is simply a case of asymmetric information, and this is why regulatory bodies exist, primarily. Of course, there's many other reasons, but also the whole intermediary market and all the services that they provide. Secondly, the synchronization of these systems is very complex. We try to do it through public APIs, we try to do it through intermediaries, like I mentioned, but yet it is very complex, and there are many issues with this. And what's more important, and I think this needs to be stressed more often, is the right of users to privacy. To be able for the regulatory body to perform its function, to perform its work, we need more and more information from the user. KYC, identity, these kinds of things, AML, etc. These are the kinds of systems that we have today, but they're running into frictional issues. They're running into issues of user privacy and the rights of the user. And in a hyper-connected world, these issues are exponentially increased. 100 years ago, we used the same paradigm to record information on paper cards, boxes, and rooms with a key and lock. But today, with our computers, information technology, the hyper-connected nature of everything, the problematic issues are much greater. It's much more exponential. And so the systems that we're looking at is how do we solve these problems at a fundamental approach, yet still be able to provide regulation, because I think it's certainly necessary. I like to protect the environment and people's rights and these kinds of things. So we have to figure out how we pull these systems together. And so, well, as I mentioned, I'll skip through this slide here. As I mentioned, we introduced these regulatory bodies, auditors, counterparties, etc., to enforce the rules. And I like to use a metaphor of two teams playing together on a football field. You know, you have rules that the teams are supposed to play by. However, they're not always honest. So we introduced the regulatory body, or the regulator, and its job is to maintain this gameplay and keep it safe and keep it correct. But obviously, they can't see everything. And of course, in a hyper-connected world, this is much more of a significant problem. So we asked the question, what if we bring the blockchain into the business workflow? What does that do? What does that change? What opportunities do we have? And when we look at a blockchain, let's take Bitcoin, for example, or Ethereum. When we look at a blockchain, by its nature, it is a fixed deterministic system. Okay, the state within the system is fixed, meaning I cannot add more Bitcoin, I cannot remove, I cannot undo previous transactions, I cannot substitute or force another user to do something. It is deterministic by deterministic inputs. Okay? And this works perfectly well in a dream of a computer scientist, because we want things to be exact. We want everything to add up at the end. An accountant, an economist, we like these kinds of things. However, the real world does not work like that. In a blockchain, we need information to be computationally verifiable so that we can form consensus around it. Which means that if the answer today is yes, the answer tomorrow must be yes, and this must continue at any point in time. In the business world, the answer today could be yes, but could be no tomorrow. And this could be many, many factors that could be introduced in this situation. So again, how do we bring these two systems together? And so what we're talking about is building up to what we call trust networks. Okay? In our traditional framework, we have hierarchical institutions that provide trust to to the population, to services, to the enterprise. In a distributed world, the nature of this trust is much different. And if we're going to make these systems work together, we have to find out how the institution can play in this world. In a distributed or decentralized world, there is no hierarchy. There are peers working together. These peers agree on protocols, and we work through protocols. And of course, we can introduce game theories, and we can introduce all the kinds of cryptography and other kinds of systems. But fundamentally, that's the difference. In the traditional world, we have hierarchy. In the distributed world, we have peers. And so the question is how do we bring the institution into the network as a peer that's able to perform its function the same way as all the other peers? Because in the peer-to-peer network, we have actors such as users and corporations and enterprises, but we also have auditors, regulators, government bodies, etc. So these entities need to work well together. So at the fundamental level, what we're looking at is what we call a proof system. Okay, and this is the beginning of what the paradigm shift looks like. In a proof system, you have primarily two actors. You have a prover and a verifier. The prover has some information that is secret in his pocket. The validator, or the verifier, must be convinced that the prover has a secret. So how do we do this? What we do is we create a protocol between the two actors, and we exchange a series of messages until the verifier is convinced that the secret exists. And I'll give a really quick use case for this. In the KYC world, I need to prove to open a bank account that I live in Paris, or that I live in France, I should say. And today's process involves me going to the UDF and getting a facture and sending all this information and documents and paperwork. But what if we were able to create a system or a protocol where I can exchange messages with my bank in a way that I can prove that I live in France without giving my personal information? Of course, this is hypothetically speaking right now. So I know there's a lot of issues in the real world, but let's just keep it at that. And so we have two ways of doing this, and I'll give some concrete examples. In the blockchain world, okay, where things are computationally verifiable, what I can do is I can ask you for a message. I can sign a message with my key to prove that, let's say, I have 100 bitcoins in my address. I can use the same key to sign your message and send the message back to you. You can verify the authenticity of my signature and therefore know that I have control over a set amount of funds. Now, in a world where the potential for euros and dollars and pounds could be possibly issued on the blockchain, this could become very useful. Okay, so that's a scenario where we have computationally verifiable information. Now, on the other side, when we do not have the ability to computationally verify this information, we have to create a trust network. Okay, so if I have a relationship with UDF and the bank trusts UDF, then what I can do is I can create a series of message exchanges with UDF in a way that information from that exchange can be used to satisfy my information requirements with the bank. I still have my information private, but because I leverage the trust network, I'm able to perform the same thing. And if we fast forward this, we can see how this can be applied to many, many systems in today's world. So as we move up, as we build on top of a proof system and that fundamental exchange, what we can see is that we can build systems where we share proofs of data in exchange for the secret or private data. And furthermore, we can expand that over a business workflow or process. So KYC is a process that needs to be performed every time I sign up with a bank or a fintech or some other kind of financial services company. If I can have sufficient proof that I have performed this process one time, and if I can use a token to represent that proof, then theoretically speaking, that token can substitute that process for any future time. So sign on. And so on this diagram here, I show the same model where you have the prover on your left and the verifier on your right. We have a series of steps or a workflow in between, and we have secret data below. And so what I'm able to do with the verifier is to exchange messages through a workflow, through a business process, to convince them that I have performed a series of steps. KYC, as I mentioned, is a great example for this. The accumulation of our work at Stratumn is building on top of these proof systems. And what we call this is proof of process. Okay, we have a white paper that's currently in draft right now. It is being peer reviewed by many players in the industry, in the space. And we expect to make some major announcements within the next month or two, which includes this work. This is the ground of what we're doing and building up. And this is our vision of how we can bring together distributed, decentralized systems and existing institutions such as the regulators, governments, and financial services. If you would like a copy of this, it's very dense and technical and philosophical, and there's a lot of theories, but we're open to share this at this point. Like I said, it is in draft, but if you would like a copy, just let me know. And so the vision that we're trying to bring to the market is going back to the game of you have two teams playing on a football field, and you need them to play by the rules. And historically, we put a regulator in the middle, but we know the limitations of the regulator or the referee. And so the vision is how do we create systems where we can program the rules into the system. And by doing that, we can offload a lot of the responsibility from the regulator while still having the same level of transparency and traceability in the system. Okay, and I think I heard someone mention about the Mini-Bone project here in France. I think that's a great initiative. If you look at how that could work, you have a regulator who specifies a series of rules that must be followed. And what we can do is we can translate that. We can translate those rules, which include both the computationally verifiable rules and also the trust rules, right? So the computationally rules would be like the smart contracts, and the trust-based rules are like KYC, AML, regulatory issues, things like that. And if we can bring those together, we can bring those two systems together where we can replace the man hours in between regulation and replace that with digital systems that are much more efficient and do not have the frictional costs that we see today. And I think I want to point out at this point that the frictional costs are a ticking time bomb. I think the next generation will not put up with it. And as the economy is under pressure right now for more jobs and more growth and more kinds of things like that, there's no room for friction. And the millennials, they don't have patience for it, right? They're going to expect something different. And if you see an option on the table of using a bank system that takes an average a week to sign up, and a Bitcoin address that I can create right now in 5 minutes and use it, like the millennials won't have patience for the two. Like they're just going to automatically select the quickest and the path of least resistance. So I think this is a very important issue that we need to work together on. As I mentioned, 20% of the talk will be on some use cases. I've listed here some of the work that we're doing currently at Stratumn and what's in progress and what will be delivered over the next few weeks and few months and something like that, which I'll go through briefly. But we are releasing a blockchain paradigm shift marketing paper. I think in French it's technically a white paper, but we call it a marketing paper. So it describes some solutions, some visionary work and things like that, but also it covers a set of use cases and breaks down the problems and how these new technologies can solve these problems. But really quickly, I mentioned KYC and compliance as throughout the talk as it's the most relevant here. But we're also looking at different systems that involve document rights. And what does this mean? And so if you think about a piece of paper, if I sign a contract with you on a piece of paper, this holds up in court. And the contract, the verbiage, the text, the agreements, and all this can be defendable in court. But it's very inefficient in a digital system. I cannot create programmable rules based off a paper contract. And in a system where you have computationally verifiable transactions, the paper just doesn't work. And so when we talk about document rights and consent, what we're able to do is take this and create the proof of this contract that can be shared publicly. And because that proof can also have the wisdom behind it, which are all the previous steps of a process, that proof can be strong enough to act as like an oracle, as a type of trusted source, so that the digital systems can rely on it. Okay, and that's again how we're bridging the computationally verifiable transactions with the real world yes, no, today, tomorrow kind of approach. We're actively working in the healthcare industry. My wife's a doctor, so we have direct access to a lot of doctors and researchers in the area, and she's actually a consultant for Stratumn. So we're doing a lot of work in the healthcare. And one of the primary examples, which is also covered in the use case book, is clinical trials research. We have problematic issues with data integrity between research labs, doctors, scientists, patients. We have the issue of patient privacy rights, what information can be shared, what cannot be shared, consent, these kinds of things. And so what we were able to do is build a system where we can share proofs of this data, proofs of these processes, proofs of the test results. And these entities can create private channels between other entities to securely share this information while relying on the public proofs to prove the validity and the integrity of the data. And this is very promising. Legal processes, we can talk a lot about the DAO and all that. I think there's a lot of interesting things that are happening in that space. But we're still in flux with the DAO. We don't know what's going to happen. We don't know if there's going to be forks, hard or soft. We don't know if they're going to just kind of deal with the situation and let the attacker keep the money and things like that. But whatever comes out of it will set very strong precedents for what comes next. The potential for being a cross between the cryptography expert and the lawyer will become more evident and more apparent as the results of this situation comes out. The business supply chain, this is primarily our work at Stratumn. And we have many use cases with like Thales and Aéroport de Paris, and we're also working with other entities in the US. And we're looking forward to bringing these results to the press, to talk about it publicly, to show concrete examples of how this works. But primarily it's about the workflow. It's about creating a series of facts that act as proof for secret data and strong, reliable source of trust so that the business processes can make decisions on these sets of data. So our team is we have a team of 9, 7 who are technical developers, and 3 who are focused specifically on research. And we're investing more and more as we're able to raise more funds. But the research behind this is really, really important. It has to be solid. It has to be peer-reviewed. The industry has to come together, both from the regulatory and the Bitcoin blockchain industry, and we need to find some synergies between the two. And so that's where we're investing a lot in right now. So I would like to just put this email address out there for now. Hello@Stratumn. If you send us an email and request a proof of process white paper or the use case book, we would be very happy to share this with you and open further discussions and private meetings to talk about this and what potential there is. I'm very happy to be here. I'm very happy to be able to have contact with you all, and I want to just express our interest in working together to bring these two worlds together. So thank you.